As you probably found, doing some optimal solution problems using pen and paper graphs, sometimes it's quite difficult using pen and paper, as the accuracy of the graph may become an issue. Using technology such as graphics calculator and Desmos can eliminate these issues, which is what we'll do in this lesson. Okay, for every lesson we need a scenario. Hopefully this is serving as good practice for you. In a pottery business, following is known. It takes an hour to make a small pot, an hour to make a large pot. Small pot requires 1 kilo of clay, large pot requires 2 kilos of clay. The staff have 10 hours per week to make pots and only 12 kilograms of lay. I assume that's clay. The profit from small pots is $10 per pot, whereas large pots, it's only $8 per pot, so a smaller margin. Find how many of each pot the business should make for maximum profit. This is getting more like a linear programming problem where there's a lot of information and we need to sort out the information from the paragraph. Okay, again, we'll start with variables. If I know that I'm going to be doing a problem using technology, I'll probably just stick to X's and Y's instead of S's and L's. Okay, so we'll define our variables. When it comes to the parameters, there's a lot of parameters there. We could list them all, but it'd get quite messy. Sometimes it's, like in this example, it's better to put the information into a table. If I have the small pots and the large pots, there's really 3 key pieces of information that I know about them. I know the time that it takes to make them and the amount of clay. The time in hours and the amount of clay in kilograms. I also know the amount of profit in dollars that I'll make for selling each type. The time to take for a small pot is 1 hour, a large pot is 1 hour. The amount of clay required for a small pot is 1 kilogram, but we need 2 kilograms for the large ones. And the profit from the small pot is $10, whereas it's only $8 for the large pot. Good idea when you're doing these to tick off all the information that you've used. Use these hours, use this clay, use the profit. The information that I haven't considered is the maximum 10 hours per week and the maximum 12 kilograms of clay. I'm going to show that in here. Maximum 10 hours and maximum 12 kilos. I can then make that into a table. Magic. And from here, I can start thinking about constraints. Just note that in here, we're not adding 1 plus 1 equals 10. See, this says maximum. It's a common misunderstanding. So when it comes to constraints, I can basically read down these columns of the table. For my time constraint, I know that the maximum number of hours I have is 10. I'm making X small pots and L large pots. It's going to take me X plus Y hours to do that, and that can't exceed 10. My clay constraint is telling me that my total amount of clay needs to be less than or equal to 12. Making X pots will require X kilograms of clay, and making Y large pots will require 2Y kilograms of clay. Those are my 2 constraints. I also have constraint that X needs to be at least 0 and Y needs to be at least 0 to ensure that there's no negative numbers of pots. When it comes time to write my objective function for profit, I better let P equal profit. That should be easy reading down the 3rd column of this table. The total profit, if I sell X small pots, will be 10X, and if I sell Y large pots, it will be 8Y. I could go down the normal route now of getting out my graph paper and graphing these, But I could also use two different types of technology. The first we'll look at is Desmos. To use Desmos, I'll just type in www.desmos.com and I'll start graphing. Since I used x's and y's, I can just simply type these equations in. So x plus y, I've even got all these signs here ready to go, less than or equal to 10, and it's already shading it for me, which is great. I'll put the time constraint in, I'll put the clay constraint in as well, x plus 2y less than or equal to 12. Okay, I've got that going. And I'll also put in my negative constraint. So x needs to be at least 0, and y needs to be at least 0. A big colourful section here. I can hide all these equations if I want to. This part that I'm tracing with my mouse is the feasible region where all these shadings overlap. So what I can then do if I'm doing an assignment or something, for example, I could just screenshot this graph. I'd probably go into settings first and add some labels here. So this was X small pots and the Y value was large pots. And just go ahead, screenshot this and paste it into my assignment or my exam. Probably exams in the future. This is what will happen. Okay, I can paste it in. I know that I'm going to be trying to find the maximum profit. So I'm going to be needing to evaluate this objective function at these three corners, 1, 2, and 3. Because I'm maximizing it, looking at the corners that are furthest away. So it's probably a pretty good idea to label those 3 points before I paste it into my assignment. From here, I know where I need to evaluate my objective function. I know that I need to look at the values where x and y are 0 and 6, 8 and 2, and 10 and 0 to look at what profit those combinations will yield. I'll probably show just the substitution for the first case, 10 times 0. So looking at this objective function, and putting x equals 0 and y equals 6 in there gives me $48 profit. The other two you can also show, or you're probably safe just to do these on your calculator. Probably don't need to show all of the working all the time. So being able to use Desmos like that will reveal that the maximum profit will occur by making 10 small pots and 0 large pots, and you'll make $100 profit. This method is most useful when the point of intersection isn't something nice that when you try to graph it on graph paper, you won't be able to read off. This one you could probably read off on a graph, but it's just for demo purposes. The other technology that we have at our disposal and will be useful in exams is the graphics calculator. Just remembering what my equations are. I want to graph these two things. X plus y is less than or equal to 10, and x plus 2y is less than or equal to 12. Unfortunately, with graphics calculator, we need to rearrange these inequalities before we can graph them. Also, there are ways that you can graph the inequalities and have it shade on your calculator, but I think for our purposes it's easier just to graph the equations. So if I call this number 1 and this number 2, when I'm wanting to graph this first inequality, I'll write it just with an equal sign and then rearrange by subtracting x both sides for something that I can graph. In equation 2, I'll do a similar thing. X plus 2y equals 12, and I'll rearrange this until I get something that I can also graph. So these are the two equations that I'm going to graph on my graphics calculator. So menu into graph mode, and I'll type in these two equations, 10 minus x, and I'll see if I can make a fraction. No, alright, you can probably make a fraction on your calculator. 12 minus x all divided by 2. So I'll draw these two things. I can't really see anything. When this happens, I'll try zoom auto and see how it goes. If I still really can't see, I can zoom out to get a bigger view, or zoom in, whatever we want to do. Maybe even zooming with a box, and you can make a box around the part that you're interested in. So I'm just interested in this little section here. It'll blow up into that section. If you get completely stuck and it's a mess like this, I recommend going to the view window, F3, pressing standard, exiting out, and you can start again. That looks pretty good to me. I'm interested in finding the intersection point between these two lines, because I've probably already graphed this by hand and found the x and y axis intercepts. So whenever I want to do a calculation, I'll use gsolve and find the intersection point. And it'll give me that intersection point there, which I can then draw on my exam paper to show that I've used that technology. One thing to be careful of with this graphics calculator is if you have, say, another function here as well, and you draw it, and say you're trying to find that same intercept point, when you press gsolve and find where they intersect, it seems like nothing will happen. All it's doing is allowing you to choose which two functions you want. So I want, yep, that. So that dot tells me it's that function. So I'll press enter on that one. And which one do I want? Oh, I also want this second function, so that when I press enter, it'll give me that same intersection point. So if you have more functions, you need to press enter a few more times. Okay, so to summarize this lesson, all this setup is exactly the same, just that when you go to graph, instead of using a piece of graph paper, you'll either use Desmos Online or your graphing calculator. All right, good luck.